Hello and welcome. My name is Krishnamurthy Bindumadhavan and this is the Financial Management course MBA ZG 521 and we are discussing about time value of money, and we have already covered how to calculate the present value and future value of a lump sum, how to calculate the present value and future value of an annuity, and remember there are two types of annuities. We have discussed about ordinary annuity and annuity due, and then we have also discussed about perpetuities. Now we are going to talk about the application of these concepts to the real world. Where can we leverage them? How can we apply them? Because we need to know the practical application, then only we can use it in the real world. So we are going to focus on that. This is part 3 and the concluding part of the time value of money section. Now in terms of applications, there are actually multiple applications, so don't think that there are only 4 applications. I have listed 4 possibilities. There are actually hundreds of applications. As I said, if you see, the common theme here is valuation. So any kind of security valuation, right, any security valuation, we will use these principles. So that is one common sort of theme that you should be aware of. But I have selected some applications so that you are aware of the actual application and how to apply it. I will be showing that as well. So 2 things that I have listed right at the top. One is NPV and IRR. Those we are going to defer to a subsequent section. So that is, we are going to cover little later in this course. We are going to talk about capital budgeting. Capital budgeting means, this is one of the important functions of the finance manager. Remember, in the introductory class, we said that evaluating the investment opportunity set and deciding which investment opportunity to pursue, which investment opportunities to pursue, is an important function of the finance manager. Whether to set up, let's say we are Intel, whether to set up the plant in China, the semiconductor manufacturing plant in China, in San Francisco in the US itself, or maybe in Singapore or Malaysia or somewhere else, that decision is called the capital budgeting decision. And so we are going to discuss capital budgeting in a later session, and when we discuss that, we will talk about NPV and IRR. Okay, but I will give you a brief idea of it right now, and then we will look at the application of time value of money for valuing a bond and for valuing equities. Equities means stocks, so valuing stocks. So let's try to understand the underlying concept of NPV first. So suppose Intel wants to set up this plant in China. Then the finance team, in association with the business team, will project the cash flows that they can expect from this plant. So let us say that it has a 5-year useful life. So then, as we know, we should always draw the timeline. So let's say it's a 5-year useful life, and let's say that they have projected that this plant is going to generate 100, that is not just $100, but let's say $100 million in each of these 5 years. Okay. Then we already know how to calculate the present value of this, right? We know how to do that. That's through the annuity formula or through the combination of perpetuity formula. Or we can also treat each of these as a lump sum. We can discount each as a lump sum, and 5 discounts we can do, and we can find this present value of the first cash flow, present value of the second cash flow, present value of the third cash flow, present value of the fourth cash flow, present value of the fifth cash flow, right? And then add it up. This sign sigma is for addition, right? And that would be the present value of the entire set of cash flows. So depending on the discount rate, that number you will get some number, right? So 10% discount rate, you will get a certain number, 15% you will get a different number, and so on. So some number you will get. Let's say we get a number, and let's say for our discussion, let's say we get a number of $300 million. At some discount rate, it will be $300 million. But let's assume that there's some X discount rate, and at that discount rate we have calculated and we got the present value as $300. So this is the present value of the future cash flows from the project. That means the returns that we are going to get. This is the current value of those returns. In today's dollar terms, this is the value of the returns. Because we can't add them. We can't say 100 plus 100 plus 100 plus 100 equal to 500. We can't say that because they are not apples, right? This is an apple, this is an orange, this is a grapefruit, that is something else, and that's another fruit. So we can't add them all. We can't say that we have 5 cash flows of $100, so the total is $500, because they're coming in different points in time. We know that $1 today is worth more than $1 tomorrow. That means that this $100 is worth more than this $100, and this $100 in turn is worth more than this $100, and so on. So therefore, these $100, this set of cash flows of $100, let us say, is worth $300 in today's dollar terms at a certain interest rate. And that we are not going to go into those details right now, or we can actually. So let me show you what I mean by that. Let's go to Excel briefly. So suppose we'll take this example. So we are saying we'll put time, and time 0, time 1, time 2, time 3, time 4, time 5. Okay, and we have got the cash flows. This is the Excel. I'm using Excel to illustrate the example of the Intel project in China, right? So they want to set up a semiconductor plant, and they have forecasted that it's going to generate $100 million cash flow every year, not in the first year actually. So that we'll correct that in a minute. So from the not in time 0, but from the first year, end of the first year onwards, it will generate $100. So it is going to generate total of $500, right? This is total $500, but we can't add them. We have to find the present value of the cash flows. So the present value of the cash flows, we'll need the discount rate for that. So let me insert a couple of rows here to add the discount rate. So by observing what I'm doing, you should also pick up how to do financial modeling or some basic models. I mean, we are not talking of complex models, but simple models. So discount rate I'm entering here. I'm going to call this as the discount rate, and let's say we will put this as 10%. Let's say 10% discount rate. Then we can find the present value of these cash flows at this discount rate. How will you find? We can use the present value function. So present value in Excel. Then we can give the rate. The first argument is the rate, and I'm going to press the function F5, sorry, not F5, F4, so that it will be a placeholder. It will hold that $D, $4, so that will hold the place. Then I put a comma. Then the number of periods. So this is actually for 1 year only we are talking about. And then this is not a payment. We will treat it as a lump sum. We will treat it as 5 different lump sums. So payment is 0, and then the future value is $100, and I close the bracket. So then I will get the present value. So what happened? We got hash value. Why did we get that? Let's see what happened. So we have given the argument. So something in the arguments is not good with Excel. So I want you to understand, right, how to enter the data. And when you face a problem, how do you address the problem? That's the question. So the rate here we have entered as $D4, that is 0.1. The number of periods we have entered as 1. Okay. And the payment we have entered as 0. And the future value we have given as D9. And then the type we have entered nothing. So that means it is 0. Okay. So this D9, it is saying there's a problem with D9. Why? Because I have entered $100 here, and so it did not like that. So let us cancel all these. It did not like that. So if when you face an error, you should know what to do, right? So that is why I am showing you that. So we'll enter only 100 here. Now we get an answer, right? So now we get an answer which is 90.91. So similarly, what I'm doing, I'm going to extend this down. So we are going to get $500 million cash flows from this project, right? Intel is expecting $500 million cash flows at the end of the next 5 years. So how to find the present value of those? We again can drag this down, and so that will give us the present value of the cash flows. Again, notice that there is a negative sign. That is the Excel convention which I have mentioned earlier. So there are 2 ways to avoid that. One is you can put a negative sign before the formula, and the other is to give the input negative. So I'm just putting a negative sign here in the formula so that we will get the positive answer. So I drag it down. So that is the present value of the cash flows. Then the total, we can simply add them up. So there is a function in Excel called sum. So I type equal to sum and then I point it to the cells. The first cell, I press down the shift button and the down arrow and then close the bracket. So that gives me the sum, which is $379.08. So if suppose the rate had been 15%, then it becomes 335. If suppose the rate is 18%, then it is 312. Suppose the rate is 20%, then it's 299. So you can see that at 20% it is about $300 million. This project is worth $300 million. So that is the present value of the future cash flows that Intel is expecting from this plant that they want to set up in China, right? So these are the future cash flows and the present value of the future cash flows, and that at 20% is equal to $299 million. Now there is a cost to set up this plant. So let's say that it costs $200 million to set up the plant. So therefore the initial cash flow, that is at time t equal to 0, the investment for this project is $200 million. Then if you net that, so this is the total present value, what we have here is the total present value. So if you net the total present value of the future cash flows against the investment cost, then that is called the NPV. So NPV means we take the present value of the future cash flows and then we subtract the investment amount, or since I put a negative sign, I'm going to add it. So that will give me the remaining amount. So in other words, after taking care of the initial investment, which is $200 million, if we set up this plant, we will be left with an extra value of $99 million. Does that sound like a good deal? And the answer is yes. Because whenever we have an NPV that is greater than 0, that means we are adding value, we are generating value. So therefore, NPV greater than or equal to 0 is what we want to target. That's the decision rule in capital budgeting. We'll study more about this in the capital budgeting, but I just wanted to give you a flavor of it. So to help you to understand the concept of NPV, which we will dig into in much more greater depth at a subsequent section. So going back to my slides, so NPV is one application of the concept of time value of money. A related application is IRR. That I will defer to the subsequent segment when we are going to talk about capital budgeting. But now we are going to focus on the application to the actual valuation of securities, real securities, right? This is actually real meaning financial securities. These are financial securities, right? So like bonds and stocks, how to value stocks and bonds using time value of money concept. So that's what we are going to discuss next. First, we will focus on bond valuation. So before we do that, we need to know what is a bond and some underlying concepts. So a bond is a promise that a company makes, right, that they will pay certain cash flows over a period of time, and in return the investor will have to lend them some money. So in other words, a bond is like a retail loan, a small loan that they are taking from XYZ. Say Mr. Ram Prasad is going to lend Tata Consultancy Services 10,000 rupees. Then they will give him a bond saying that, yeah, we have borrowed 10,000 rupees from you, and in return we are going to make an interest payment, which they call as the coupon. The interest payment in the bond is called a coupon. And how long are we borrowing? Is it for 5 years? Is it for 10 years? Is it for 20 years? That will be stated. That is the term of the bond, or the time period of the bond, the maturity of the bond as we call it. And then the face value or the principal, how much they are borrowing, right? The principal that they are going to return, that 10,000 rupees or whatever it might be, right? So those are the characteristics of a bond. So the bond will have a certain par value or face value or principal value. They are all the same things. Par value means face value means principal value. Then it will have a coupon. The C stands for coupon. Coupon is nothing but the interest. The periodic interest that is paid is called as a coupon. Okay, and then there will be a certain time frame after which the principal will be returned, which is called the maturity of the bond. That might be 5 years, 10 years, 20 years, or it might be short term, 1 year, 2 year, 3 year, and things like that. Okay, so we want to see how to value the bond. Understand the terminology. The terminology is, the bond is called an indenture. It's a legal contract, and it promises to pay the investor certain cash flows, which are in the form of coupon. Coupon is the interest payment, and at maturity it promises to return the principal. And that indenture or the contract will also define the time frame of the bond. That's called the maturity. Okay, so these are all the terminology that is associated with bonds. Now, understanding this terminology, let us try to value a bond, right? And we know that the fundamental principle that we will be leveraging is called the time value of money. And that means that $1 today is worth more than $1 received in the future. Okay, which means that we will have to forecast these cash flows, and then we'll have to find the present value of these cash flows. That is how we will value any security. To value any security, this is the sort of the most important concept in all of finance, right? If you pass out of this course, then one thing that you should definitely remember is that the present value or the market value of any asset is equal to the present value of the forecasted cash flows from that asset. That is how we should value any asset. Okay, we should not look at the past. What it has done in the past is irrelevant. What we are interested in is what are the future cash flows, and then we discount those cash flows and find the present value. That is how we value any financial asset. Okay, so therefore, what do we need to do? We need to estimate the size and the timing of the cash flows. When are the cash flows coming and how much? We need to determine the correct discount rate, because we have to discount it to present value. And then, of course, once we know these, then we can find the present value. In the case of bond valuation, the size and the timing of the cash flows are defined in the bond contract. So therefore, it makes our life easier, right? We don't have to estimate anything. It is already in there. The discount rate also, that's the only thing that we may have to estimate. But for our purposes, we have a shortcut. That is, we will use a rate that is published, which is called the YTM. Okay, so once we know these things, then it is a simple matter to discount the cash flows and then find the price or the present value of the bond. The present value is the correct price of the bond. Okay, the value means the present value, and that is the market price. That should be equal to the market price. So let us apply this concept. Let me summarize the formula. And then we will apply the concept. So the value of the bond will be equal to the present values of the cash flows generated by the bond. So what are the cash flows? As we just said, it is going to pay us, let's say it is a 5-year bond, then it's going to pay coupon, right? That's the interest that it is promising to pay. And then it will return the principal or the par value. These are the cash flows or face value. So what do we have to do? We have to discount this to today. Discount this. Similarly, we have to discount all of these. So if you discount it, then that's what we are showing here. This coupon discounting we are showing in a summary notation. What is it? It is the sum of Ct divided by 1 plus r to the power t. For the first one, it will be nothing but C1 divided by 1 plus r. Second one, C2 divided by 1 plus r to the power 2, and so on. And then this par value we are discounting by time t, because that is what we are saying, that maturity is at capital T. Okay, so that's the formula here. So using this formula, we can find the price, the correct price that the bond should be trading at. Okay, so that's how we value the bond. Let's try to apply this to an example. We want to value a 10-year bond which is paying 10% coupon, right? And assuming that the discount rate is 10%. This is also called YTM. Okay, or YTM stands for yield to maturity. Another term that we will be discussing little later in the course in much more depth. Right now, you think of this as the discount rate. Okay, think of this as the discount rate, but we will explore the yield to maturity concept a little bit more in a subsequent segment. Right now, for our understanding, because we are trying to understand the application of time value of money, we will think of this as the discount rate that we are going to apply. The coupon rate and the discount rate are different. here we have given the same numerical value 10%, 10%, but don't confuse them. The coupon rate is the interest that we are going to get on the bond. The discount rate is the discount that the rate at which we are going to discount those cash flows. So they are two different things. So let us do this example. So here is the question. What is the value of a 10-year 10% annual coupon bond if the discount rate is 10%? So this is how we should build a model. Through this I am also illustrating how to build a financial model. First we have to list the assumptions. Okay, so that's what I have done over here. We need to list the assumptions. So in this segment, in this section, I have listed all the important and relevant assumptions. Okay, so what are they? Maturity is in 10 years. The discount rate is 10%. So I am also trying different discount rates, but let's put 10% for now. The coupon rate is also 10%. And then the coupon amount. The coupon amount will be the coupon rate multiplied by the principal. So the principal is $1,000, we are assuming. It is not given, it was not given in the problem. So if it is not given in the problem, the default is 1000 rupees or $1,000 will be the default. Even on the exam, if we have not given the dollar amount for the principal, that is the face value or the par value of the principal, then assume $1,000, but state your assumption up front when you are solving the problem, right? Whether it is a homework problem or whether it is an exam problem, you should follow the same approach. So here we have made the assumption of $1,000, and the coupon amount will be nothing but the rate multiplied by the principal. So 10% multiplied by 1000 gives us the $100. Okay, and you can see that I have put it in a formula, right? You should always do that. That is one of the essential principles of financial modeling, because if you don't do that, if you directly put 10% into 1000, you will still get the answer as $100, right? So suppose what I am trying to say here is, if I put 10% into 1000, then I will also get 100 here. But suppose tomorrow I want to change this coupon rate to 12%, then my answer is not changing because I have hard coded. That's a problem. That's a fundamental flaw in modeling, and we should never commit that. We should always put it in a formula. So I take this cell and I multiply it with this cell, so that now if it is 12% we get 120, and if it is 10% we get 100, and if it is 8% we will get 80, and so on. So that's how we should build a model. Never hard code. Hard coding will lead to problems, especially when the model gets complex. Then it will lead to serious problems. We may not be able to even discover. The main problem with hard coding, in a simple model we can easily see what's going on, but when the model becomes very complex, we may not even realize that there is a problem. So that's why we should always avoid hard coding. Okay, although this is a very simple model, follow the fundamental principles of modeling, which I will talk to you about as we go along. Alright, so now we have got all the assumptions in, and we need to find the price or the present value of this particular cash flows, the cash flows that this particular bond is going to generate. So how do we do that? One method is by using the by using the annuity formula. So we have this annuity formula, so we can use the annuity formula. So here's the dialog box. It asks for the rate, and the rate, that is the discount rate, is in cell C6. So I have given that. Then the number of periods, that is in cell C5, 10 years, I have given that. Then the payment we know is $100, that is in cell C8, I have given that. Okay, and then we need to, so that's for the annuity, right? So then we just say okay, so that gives us the value of the annuity. Okay, this is the value of the annuity, but this is the value of the annuity without taking the principal or the par value into account. So if you have to take the par value into account, then you have to then there's the second step here, which is the lump sum that we are getting, the $1,000 lump sum after 10 years. That's the principal that is coming back to us. So how to find the present value of that principal? We use the lump sum, the same PV function, but here the rate is still the same C6 cell, which is 10%. The time period is 10 years, and payment is 0 now, and we put a future value which is C9, which is the principal $1,000, and if I press equal to, then I get 385. So if I add these two, then I will get the price. So adding these two, that is I am adding C13 plus C17, right? So if I add these two, then I get $1,000, that is the price. So what have I done here? What have we done here? We have done an annuity, right? Remember, there is an annuity of $100 for 10 years, and then we are getting $1,000 at the end. So we have found the present value of that as well, and we add these two and we got $1,000. Now what is the second method? In Excel, we can combine the lump sum also with the annuity. So that is the second method. How do we do that? Well, we enter the rate as before, which is cell C6, which is 10%. Then we enter the number of periods, which is cell C5, which is equal to 10 years. Then we enter the payment, which is the coupon amount, which is $100, which is in cell C8. And then this is the difference between the first method and the second method. I am also entering the future value, which is in cell C9, which is the principal of $1,000. And if I click OK now, then I am getting directly the $1,000, which is the same as the first method answer. So both methods are giving the same answer. Then I have a third method, and in this method I am showing each of the cash flows separately. So first cash flow of $100 after 1 year, second cash flow of $100, and so on for 10 years. And in the last year, we are also going to get the $1,000. So therefore, the total cash flow is 1,100. Then I am finding the present value of each of these cash flows. Using the same, I can either use the same present value function, or I can actually do the calculation. I have shown the calculation here, which is I am taking the $100 and dividing by 1 plus r raised to the power of n. Okay, so that's what I have done. I could have used the present value function also, that will give me the same answer. And then I add all of these, and that gives me the same $1,000 answer. Okay, so either which way, either of these methods, and there are other ways also that we could possibly calculate this, but either of these three methods should give the same answer. Okay, if you have done it correctly, whichever method will give the same answer. So what we have done is we have found the price, the market price or the present value of a 10-year bond with 10% annual coupon and at a discount rate of 10%. What is the value of the bond? We have found using three different methods. Now I want to illustrate one concept here. Why did the market price or the present value turn out to be $1,000? The principal of the bond is $1,000. That is the money that the company will return to us at the maturity of the bond. And why is the market price of this bond also $1,000? The reason is that whenever the discount rate is equal to the coupon rate, then always the price will be equal to the par value. Okay, then we say that the bond is trading at a par. Whenever the discount rate is equal to the coupon rate, then always the bond will trade at par. But suppose the discount rate is more than the coupon rate. Let's put 12%. Then what happens? What do you think should happen? Think for a minute. If the discount rate is more than the coupon rate, what should happen? Will it be more than 1,000 or less than 1,000? Of course, don't look at the answer that is there on the screen. Think about it by yourself. What should happen? The answer is it should be less than 1,000 because we are discounting it back. So when we are going forward, we are having a lower rate. When we come back, if we are having a higher rate, that means the value will turn out to be less. And you will see that we are going to get something less than $1,000. So whenever the discount rate is more than the coupon rate, then we say that the bond is trading at a discount. Okay, so we say that the bond is trading at a discount. And on the other hand, if the discount rate is less than the coupon rate, let's say 8%, then we will have a value that is more than the principal amount, and we say that the bond is trading at a premium. Okay, we say the bond is trading at a premium. So those are sort of the nomenclatures. Now let's understand why. Intuitively, let's try to understand why is this happening. First, we will try to understand intuitively. Mathematically also, I will give you an example. I'll explain a little bit. But intuitive understanding is very important. So let's take this example. Our bond is paying 10% interest. That's what the coupon rate of 10% means. That means our bond is paying $100 interest. Discount rate is 8% means, what does it mean? It means that other comparable bonds issued today, because this bond might have been issued in the past. 2 years ago it might have been issued, or 5 years ago a 15-year bond might have been issued by the company, and today it is a 10-year bond. And at that time, the interest rates prevailing in the market might have been 10%. So we issued a 10% bond. Remember, interest rates are constantly fluctuating. And so today the interest rate is 8%, which means other bonds that are being issued today are only going to pay 8% interest. But our bond is paying 10% interest. That means our bond is paying $100, and because other bonds in the market, other comparable bonds, that is important. Of comparable means comparable risk. Other comparable bonds are only paying 8%. So if other bonds are paying 8%, that means what? You will only get $80 from other bonds. So if other bonds are paying 8% interest, that means they are going to pay only $80, and your bond is paying $100. Why will you give your bond away for 1,000 rupees? Will you? If you give your bond, if you sell your bond at par, if you sell it for $1,000 and then you turn around and try to invest in another bond, that will only pay $80. Whereas right now, if you hold on to your bond, you are going to get $100. If you sell this bond and only get $1,000 and you try to invest the $1,000, you will only get $80. That's a loss for you. So you won't do that. So you will demand a premium. That's the logic. So if our bond pays a coupon which is more than the prevailing rate today, then we will demand a premium. That's why it's called a premium bond. On the other hand, suppose the discount rate is 12% and our bond is only paying 10%. What does that mean? That means that other comparable bonds are paying 12%. Okay, so if other comparable bonds are paying 12%, let's put it in another row here. So if other bonds are paying 12%, this is case B. That means other bonds are paying $120. So this is our case A, we have already discussed, and now we are talking about case B. So if other bonds are now paying 12% and our bond is only paying 10%, that means other bonds are going to pay $120 interest and our bond is paying $100 interest. So if you try to sell your bond and demand $1,000, then they will say, wait a minute, if I give you $1,000, then this will give me every month $100. But if I go to the market for the same $1,000, I will get a cash flow of $120. So why should I give you $1,000? They will demand a discount, because if their $1,000 they invest in a current market bond, in another bond of comparable bond in the market, they are going to get 120. That's what the discount rate is suggesting. So therefore, they will not invest in your bond. If you charge $1,000, you have to sell it at a premium. So therefore, whenever the discount rate is more than the coupon rate, we will have to sell the bond at a discount. Whenever the discount rate is less than the coupon rate, we can sell it at a premium. And when the discount rate is equal to the coupon rate, then the bond will sell at par. That's a little bit about bonds. But really, the application of the concept of time value of money was the focus here. But through that, we also learnt a little bit about bonds, and hopefully this has given you some useful insights. So let's go back to the slides. So here we are. So we have seen how to value this, and we actually did it in Excel. I just have a couple of slides on this. So I'll go through that quickly. I won't spend too much time on it. This is by each cash flow. So this was the third method that we did. Each cash flow we valued and then we added it up and we got $1,000. In Excel, I showed you 3 different methods. What I have in this slide is the third of those methods. Okay. Now we will shift gears and talk about stock valuation. So far we have talked about how to value bonds. Now we are going to talk about how to value stocks or shares, right? Now, when we talk about stocks, there are 2 types of stocks. We have what is known as the preferred stock, and then we have the common stock, right? So stocks are of 2 types. When we generally say stocks, we are referring to common stocks. Preferred stocks are a slightly different type of stock. Preferred stock owners do not have voting rights. They are not bearing the risk of the company. Preferred stock is somewhat like a bond, somewhat similar to a bond, but the tax treatment is slightly different. Preferred stock means you are given a fixed dividend. The dividend is fixed, common stock, the dividend is not fixed. If the company does well, they will pay a bigger dividend. If the company doesn't do well, they may pay a smaller dividend, or they may not even announce a dividend, right? But preferred stock, essentially, they have to guarantee the dividend. If they don't pay the dividend because the company did not do well, then it becomes cumulative. That means next year they have to give that dividend. Otherwise, they cannot give any dividends to common stockholders. Without paying that accumulated dividend, they cannot issue any dividend to common stockholders. So, preferred, however, is not having a finite life. Just like a stock, it goes on forever. Bond has a finite life, but a preferred stock does not have a finite life. So, that's the difference between a bond and a preferred stock. So, it is like a perpetuity. It's a perpetuity. So, that's an application of a perpetuity. So, I told you earlier that there are no real perpetuities. In fact, there are, in the sense that in the preferred we can think of it as a perpetuity. Okay. So how do we value it? We take the dividend and divide by the required return on the preferred stock. That's as simple as it gets, right? So valuing a preferred stock is very simple. All we do is we take the dividend and divide by the required return. So here's a simple example. There's a preferred stock with a $100 par value. That's extra information that is not relevant. The dividend, that is relevant because that is required in the numerator, so we need that. And then the rate of return, we need that, so that is in the denominator. So all we do is take the $8 and divide by 9%, and we get $88.89. That's how we would value a preferred stock. One point I want to mention here, this $100 par value, why was it given in the problem? That is an extra information, and even in my exams, I may give some extra information. So don't feel compelled to use all the data that is given in a problem. Okay, why is that? Because in the real world also, we are flooded with information. The real world, we are not told that, okay, we have to apply this, what do you call that, perpetuity formula. And for that, this is the amount and this is the discount rate. Are we told like that? No. The real world, the problem doesn't come with a framework defined and with the inputs defined. We have to pick out what is the correct framework to apply, what are the relevant inputs. We are bombarded with data, and we should be in a position to analyze that and pick out the relevant information. So to mimic the real world, because this is work integrated learning, and even outside of work integrated learning, that is the approach I take. To mimic the real world, I may bombard you with additional information in the exam as well. So be warned. So don't think that you should use all of the data. This is just a simple example of that. Okay. So you should use your analytical thinking to extract what is relevant for answering the problem, and then use that data alone to solve the problem, which is what we did here. Now a follow-up question: if the market price of the preferred stock is 95, will you buy it? Well, our valuation tells us that the fair value should be 88.89. If the market is valuing at 95, what does that mean? That means the market is overvaluing it. So what will you do? Will you buy it? No, we will not buy it. How about if the market price is 80? Then there is upside. If you buy at 80, according to our model, simple model, but nonetheless a model, we are forecasting that the fair price is 88.89. The market is currently not valuing it correctly, and we think there is upside potential, so therefore we will buy it, right? So that's how the financial analysts work. That's how, if you watch CNBC show, and you will see financial analysts talking about whether we should buy a stock or sell a stock, this is how they analyze it. I'm showing you simple ways of doing it. Of course, they will bring in more and more complexity. Modeling means what? Modeling means we are trying to model the real world, right? When real world is very complex, we will try to bring in some simple assumptions to model the real world, and we are taking baby steps there. So, and indeed, this is the model for perpetuity and preferred stock. This is the simple model that even the most sophisticated analysts will use. But the other models that we will look at for common stock, we will only look at the simpler models. Those analysts who come on CNBC may look at more complex models, but at least this will give you an idea of how it works, so that you will see how we can actually apply these concepts in practice. Okay, so next we will talk about valuing a common stock. So valuation of common stock is probably out of the things that we are looking at, is probably the most difficult, and indeed it is more difficult than valuing a bond or a preferred stock for a number of reasons. In the case of bonds and also in the case of preferred stock, we knew the size of what? Size of the cash flow, because we know the coupon rate and we know the dividend. It is fixed. The dividend for preferred stock is fixed. We know the timing, and in the case of the bond, we know that there is a certain timeline, that is the maturity. In the case of the preferred stock, we know it is for infinity, so we can apply the perpetuity. In the case of the bond, we know it is a finite set of sequential cash flow, so we will apply the annuity. So since we know the size and the timing, it becomes much more easier. But when we talk about common stock, that is not the case, because the common stockholders are the suppliers of risk capital. That means that if the company is doing well, they will get a bigger dividend. So that means the size will go up if the company is doing well. If the company is not doing well, then the size of the dividend might come down, or there might be no dividend at all, which means that we have a problem with the timing. They are not going to be sequential. Some years there may be no dividend payment. Other years there might be a bonus dividend payment. So therefore, with a common stock, it is much more difficult to estimate when we will get the cash flow, if at all, and how much we will get, we don't know. So there is much more uncertainty when it comes to valuing common stock. That's why those analysts who come on CNBC, they are highly paid, because they have to actually come up with the forecasts of these cash flows. That is going to be very difficult. We are not, fortunately or unfortunately, maybe fortunately, because this is an introductory class, we are not going to go into those details, but we will understand the mechanics, how it works, how they apply these concepts. So for us, some of the inputs will be given, and what we are going to do is we are going to use a very basic model to value the common stock. In this model, which is called as the DDM model or the dividend discount model. DDM stands for dividend discount model, or discounted dividend model, or dividend discount model, either way. We will value the common stock by calculating the present value of the forecasted future stream of dividends. So what we are going to do is, we are going to forecast what the dividends the company will pay in year 1, year 2, year 3, and so on. We will forecast what the dividends will be, paid, dividend 1, dividend 2, dividend 3, and so on. We will forecast, and just like we valued the bond, we will discount all these dividends to today, right? And then we will add it up, and that will be the value of the stock. So that is how we are doing. So we are simply discounting all the dividends appropriately, right? So it goes from n is equal to 1 to capital N, and we have to raise it to n or t. I think we have got t, so I should use t. So the correct formula would be summation of t is equal to 1 to capital T dividend at time t divided by 1 plus the interest rate k to the power of t. Okay, so this is how we are going to value the common stock, by forecasting these dividends and then discounting them to today. Because these dividends may not be equal, we have to assume that they are all unequal. If they are equal, we could use the annuity formula. But if they are not equal, then we have to treat this as one lump sum. We have to treat this as another lump sum, and then each of them we have to discount individually and then add them up. That's what I have captured in this formula here, right? So that is how we would find the market price or the present value of a common stock. Let's look at a couple of variations to this, couple of cases, and try to value it. Suppose we are only going to hold the stock for 1 year, right? So what we are saying is, we have a stock which paid $1 dividend last year, and we think, or we have estimated, that the dividends will be 10% higher next year, and we believe that we can sell the stock for $25 and the discount rate is 11%. Then what is the fair value or the market value of the stock? So we'll forecast. So what we are going to say is, it's only for 1 year. At the end of 1 year, what are we going to do? What are we going to get? We are going to get a dividend, and then we are going to sell the stock, so we'll get the selling price. So if you discount both of these to today, right, and find the present value, that should be the fair value. So what will be this dividend after 1 year? Well, last year it paid 1%, and next year it's going to be 10% higher. So it will be $1 multiplied by 110. So it will be $1.10. So that is the expected dividend. That is the expected dividend next year. And then we know that selling price is already given in the problem, $25. So therefore we can find the fair value. So I have captured that in a formula here, which is the dividend next year divided by 1 plus k, the selling price divided by 1 plus k. So substituting all the data in the formula, we get the answer as 23.51. This is a very simple application of time value of money, okay, where we have made a number of assumptions. We are assuming that we can sell it for $25. We are assuming that the dividends will grow at 10%, and knowing the last year dividend, we can forecast the next year dividend at 110. And given all this, all we do is discount it at the rate which also is given to us. In reality, calculating the discount rate itself is an exercise, right? Forecasting the cash flows is a bigger exercise. So we have simplified it so that we can apply the concept and understand how to apply time value of money for valuing a common stock. So this is for 1 year holding period. What about if it is for more than a year, for multi-year holding period? How do we do it? The concept is the same. So instead of forecasting for 1 year, we will forecast the dividend stream for future years. So it could be for 3 years, it could be for 5 years, and so on. So in this example, it is for 3 years. So what we are saying is we are going to hold the stock for 3 years, and we are going to forecast the dividends. What might be the dividend after 1 year? What might be the dividend after 2 years? What might be the dividend after 3 years? And then we are also going to sell it after the end of 3 years at a certain price. So here we are told that the selling price after 3 years is 57. We are making the assumption. And we are told what is dividend 1, what is dividend 2, what is dividend 3. We are given. So then what do? We have to discount each of these to today. All we have to do is discount it and then add it up. So that's what this formula is telling us, right? This is the 3-period formula. Or you can generalize it to n periods. I have shown for 2 periods, 3 periods. You can go for 4 periods, 5 periods, whatever. So then it's a plug and play. All we are doing is we are plugging the data into this formula, and we get this answer, which is $40.37, right? Very straightforward, because we know all the dividends and we are given the selling price also. These are all the assumptions, and we are given the discount rate, which is 15%, right? So that's given here. So then we discount the cash flows at 15% and add them up, and we get 40.37. Suppose the market price of this stock is $50. Is it a good idea to buy? No, because the market is overvaluing it, right? So if the market price is $50, then it's not a good idea to buy the stock, because according to our model, the value is only 40.37. If the market is overvaluing it, then we should not buy it. On the other hand, suppose case B, if the price in the market is $35, then if you buy it for $35, what our model is predicting is that we can sell it in the future at 40.37, because that is the fair value based on our assumptions and our modeling. So then we should buy it, right? So here we should not buy it, here we should buy it. That's the implication. So that's how the stock analysts make so this is sort of the underlying principle of how the analysts analyze, and then they will make recommendations whether to buy or sell. This is the underlying principle. Okay. Infinite period. What if we forecast the dividends for an infinite period? So we are starting here. First we talked about 1 year. Then we talked about multi-year, 2 years, 3 years. We looked at a 3-year example. What if it continues on and goes on and on forever, right? Then is there a way to model it? And the answer is there is a model called the constant growth model. Another name for this is the Gordon model, or the Gordon constant growth model, because Gordon is the researcher who came up with this particular model, who developed this model initially. I don't remember when, but some time back. So Gordon constant growth model. What this model is saying is that if suppose we have dividends, last year the dividend was 0, And suppose we know the growth rate of the dividends. So let's say that the growth rate is G. That means the next dividend will be the dividend last year into 1 plus G, and so on. It will keep on growing, right? Dividends are going to grow. So that means what? Dividend 1 will be dividend 0 into 1 plus G. And what will be dividend 2? Dividend 2 will be dividend 1 into 1 plus G, which will be nothing but dividend 0 into 1 plus G squared, right? And so on. So you can calculate for others. So it's a geometric progression again. It is growing at the rate of G. Okay, this is a geometric progression. And we know that the discount rate we are given, let's say the discount rate is given as K. Okay, so the discount rate is K. So given a discount rate of K and given a growth rate of G, it's a constant growth rate. That is one of the simplifying assumptions of the model. In the real world, that may or may not be the case. But again, like I said, modeling means we are going to simplify the real world. If you take the entire complexity of the real world, then the model will probably bomb, because it will become so sophisticated or so complex that we may not get any meaningful answer. So we have to always simplify the reality if you want to get some reasonable answer. And whenever we make decisions using a model, we have to recognize the limitations of the model also. And one of the important limitations or the definition of model is that it is a simplified version of the real world. But to the extent that we can still rely on it, I mean, based on the assumptions and based on the inputs, given a certain context, we have to do it. There's no other alternative. Because if you try to mimic the entire real world, you will first of all need a supercomputer to be able to model that. And that's why for weather modeling, they use supercomputers. And still what happens? The meteorologist says there will be no rain today, but we have heavy showers. Next day he says there will be rain, but there are no showers. So modeling is a complex business, and modeling can be applied in many different contexts, right? Weather modeling is one, financial modeling is another, and we have modeling in other contexts like oil exploration, things like that. Anyway, the point here is we should simplify the real world so that we can get a reasonable model which can give us modeling. One of the principles of modeling is keep it as simple as it can, but no simpler. That's what I think one famous person, I don't know if it is Einstein or somebody, has said that. Keep it as simple as possible, but no simpler, right? So you should not oversimplify it, but you should not make it overly complex either. Though that's a fundamental principle of modeling. So anyway, to the extent that the model is a good representation of reality or a reasonable representation of reality, then our answers will also be reliable to that extent. Okay, so in this case, what we are saying is we are going to assume that the dividends will grow at a constant rate. For some companies, that might be valid and reasonably accurate. So then we can apply this. So that rate is G, and then we have a discount rate which is K. Then since it's a geometric progression, we can apply that concept to show the formula actually simplifies. So when you add all these present value terms for the dividends until infinity, then it simplifies to this formula, which is a very simple formula, which is that the value of the stock today is equal to dividend next year divided by the required return minus G. This is the formula for the Gordon constant growth model. Okay. The derivation of the formula, again, we are not going to go into it, but you should know the formula and you should know when to apply it, and you should know the underlying logic and intuition. The reason it simplifies to this is because of geometric progression. Again, the common thread is geometric progression in several of the simplifications that we have looked at so far. So now here is a question. A stock paid $2 dividend last year. That means it is the dividend 0, right? And if dividends are going to grow, at 5% forever, and the required return is 12%, then what is the fair value of the stock? So we have to find the dividend next year. K and G are given, but dividend next year we need to calculate. Dividend next year is dividend last year into 1 plus the growth rate. So that gives us $2.10. So then if you plug and play into this formula, we get the answer as $30, right? Now in this formula, notice that the relationship between K and G is very important. If K is less than G, then what happens? That means to say, what I mean to say is, if g is more than k, then what happens? Then the denominator will become negative and we will get a meaningless answer. So one important thing for this model is that k should always be greater than g. And how different are k and g? If the gap gets narrower, the denominator becomes smaller, then the answer will become larger. If the gap gets wider, then the denominator will become larger and the answer will become smaller. So this relationship is very important and you should understand that concept. Okay, is it clear? So essentially we can apply this model, the dividend discount model, if we believe that the dividends will grow at a constant rate forever into the future. Thank you very much. Let me quickly summarize what we discussed and then I will close out. So we have talked about the applications of time value of money. First, I talked about net present value and I explained that net present value and IRR, which are related concepts, we will explore these concepts in a subsequent class, that is the class on capital budgeting. But I did give you a sneak preview into NPV, that is net present value, which is one application of time value of money. Then we looked at how to value a bond using the time value of money principles. A bond is nothing but an annuity, right? We can think of it as an annuity. Plus, of course, the par value which comes at the end is a lump sum, so it's a combination. And I showed you in Excel using 3 different methods how to value a bond. And then we looked at stock valuation, wherein we looked at preferred stock, which is nothing but a perpetuity. And then we looked at common stock, where it gets a little bit more complex, but we simplified it using the simple dividend discount models. And we looked at 1 year holding period, we looked at multiple holding period, and we looked at the Gordon constant growth model. Thank you very much, and I'll catch you in the next class. Bye for now.